This is Calculus Unit 5, Day 44 notes, and we are on Part 2. We're still working on particle motion. And what we're looking at here for this, the first definition, definition of net distance. So this is the distance between the point of origin and the final position. So if I just start at point A, and that's at 1, and I travel to point B, let's say that's at point 7, and I go from A to B, my net distance is 6. And what we're going to learn here is it really doesn't matter if I went right from point A to point B, or if I started at A, went a little bit to the left, came back up. Where did I start? 1, ended up at 7, so I'm at 6. Or even if started at A, went a little to the right, went back to the left a little bit, went back to the right a little bit more, but then ended up at 7. I started at 1, went to 7. Net distance is 6, and we're going to formally define that down below. Total distance is the sum of all distances moved in any direction, and we'll formally define it. It's not a great formal definition, but what we could do is, hey, I go from 1 to 7, that's going to be 6. But now, if I travel 1 to the left, that's 1, and I'm looking at absolute value here. Then I had to go 1 to get back to A, that's the second one, and then 1 to 7, 6, so that's a total distance of 8. Here, if I went 1 to the right, then back to here, that's a total of 3. Then back 1 there, that's 4. 6 is there is 10. 3 there's 13. 3 back 16. So we're starting to get, hey, that's total distance. So let's formally define these. Well, first thing, if the particle's moving in the same direction the entire amount of time, what we're going to find out is that the net distance and total distance are always going to be the same. Again, only if it's moving the same direction the entire time. Okay, so now the formal definition for what we have to find the net distance is the value of the function, position function, p of a, it could be s of a, p of a minus p of b, and then we take the absolute value of it. Okay, and I just want to make sure it doesn't look like the L continued. So the absolute value takes out all negative signs. It doesn't matter where you start. If I start at 1 and go to 6, so 1 minus 6 is the same as the absolute value of 6 minus 1. Again, the absolute value of that. Either way, it's going to be absolute value of 5 or the absolute value of negative 5, which is a net distance of 5. Okay, where it gets a little tricky is when we're starting to look at total distance. So on the interval from A to B, and this is including A to B, the total distance is the absolute value of PA minus PB. Again, provided the particle is moving in the same direction for the entire interval A to B. Now, but provided the direction of motion changes for time equals c on the interval a to b, and it changes somewhere in there, then the total distance is going to be p of a minus p of c. So that's while I'm going to a to b and I change it all, and this is just one time, but I could change an infinite number of times, and I kind of give you those examples up top. It's the absolute value of p of a minus p of c, and then add to that the absolute value of p of c minus p of b. Now, if I change multiple times, it'd be P of C minus P of D, and then P of D minus P of E until I get to, hey, P of E minus P of B. However many stops I need to do, but every single time I add the absolute value of the difference, which will give me those small components of changing directions. Okay? So there's a problem here that we're going to look at. Position of a particle is given by the function P of t equals 2t cubed minus 6t squared plus 8t, where p of t is measured in centimeters. Find the net and total distance the particle travels from t equals 1.5 seconds to t equals 4 seconds. So the net distance is going to be p of 1.5, and let me get my calculator in here. So let's do that. Hold on, let me quit this. And I have this in here. Um, so if I go to my data table, table set, and I want to start at 0, and I'm going to change by 0.5, and let's look at what my table is. So at 1.5, I get, and I have both equations in there. I don't know if you can see it up there because I also have the derivative, which we're going to need in a second. But at 1.5, it's 5.25. So this is the absolute value of 5.25 minus the value of the function at 4 seconds. Let me go down to when it's 4 seconds. That's 64. So let's put that in there. Minus 64. And hey, that's going to be negative 58.75. But then since it's absolute value, it's going to be 58.75 centimeters. And that is our net distance. Okay, now they want to find the total distance. So a couple things. I said I had to take the derivative. Why do I have to take the derivative? Well, I want to see if the derivative's positive for part of it, then it's moving to the right. And if it's negative, then it changes direction. And I go back to positive. But if it's either always negative or always positive, then I know it's always in the same direction. And it would be the exact same as the net distance. Well, let's first take a look at what the derivative is equal to. Okay, so I went in and I already put this in the calculator. Let me just go to y equals. Let me shut off the position function. Let's go zoom standard. It's quadratic, and I notice, hey, it's a quadratic with the vertex right here, positive value, and it opens up. So the equation of this, and that's right here, that 6x squared minus 12x plus 8. So I know my derivative's always positive, and they're really only talking about the interval from 1.5, which is here, to 4, which is up here. That interval's always going to be positive. So let's write some information down about what I know about what must be true. So since, and again, that's the derivative of the position function, that's v of t, and since v of t is always going to be positive, well, always, and I'm just talking about when t is between 4 and 1.5, which for us is the always, therefore the particle's always going to be moving to the right, and since the particle's always moving to the right, then the total distance traveled is going to be the exact same as the net distance. And that's going to be it for part 2. Let's jump over to 44 notes, part 3.